In the session 1 of wireless connectivity, we saw one of the protocols in the long range category. Today we'll see two or three more in the same long range category. Tomorrow I will talk about short range wireless technologies. Why I'm spending time on this is, I told you many times, you need to understand the pluses and minuses of each of the technologies, and you should be in a position to choose one of them for your application. Okay, or even if you have one choice already made by someone, you should be able to scrutinize whether it is good or bad, what are the problems with that, and then when you are developing software on that, you have to comprehend this in your software. Because, for example, if you are connected to a network which is not reliable, okay, you know some technology which is not reliable and it may go off air intermittently, then your software should be in a position to take care of that kind of a situation. So you need to have that knowledge of what technology you use. I'm not asking you to know inside of what is inside going on, but at least you should know what are the pluses and minuses of that technology and how to comprehend it in your system, okay, in your software. Or if you are a designer, you should be in a position to choose one of them and then cater for that kind of a requirement in your design. So suppose if you are choosing something which needs more power, that you need to take care in your design that battery power is sufficient enough, and the lifetime of that device, if it is not going to be replaced, the memory battery is not going to replace, how to make it increase the lifetime of that device. There are so many things involved. Okay, so let us now go into a couple of technologies, these two, and then I will talk about 5G, which is upcoming, and the recent trend. We'll cover all of them today. So LPWAN, I'm sure all of you remember, is not long. It's low power wireless or wide area network. It's not wireless, low power wide area network. NB is narrow band. Now, what I mean by narrow band is about the frequency. Okay, how much of frequency bandwidth we have in this technology to come to transmit as well as receive. Now, when I say bandwidth, it is some range of frequencies. It could be some 2.4 to 2.425 gigahertz. So it is normally in terms of ranges F1 to F2, and it will be given in terms of 100 hertz, 100 kilohertz, or maybe 10 megahertz. This is absolute term, okay? But it will mean that it is between these two frequencies, we have a bandwidth of 100 kilohertz. That means from 2.4 gigahertz to some 2.4 something, which gives you the difference. F2 minus F1 will give you the bandwidth. So sometimes it is represented in terms of absolute frequency terms or range of frequencies, because range of frequency is very important to know where it is operating. Then you will have a better idea. So narrow band is, this technology uses narrow band frequency. That means when the band is narrow, suppose frequency is ranging from kilohertz to gigahertz, right? Now, suppose if I say that it is 2.1 kilohertz, my bandwidth is from 2.1 kilohertz to 2.2 kilohertz, and then I say that other communication is from 2.4 gigahertz to 2.41 gigahertz. Okay. Now these two are not same, because if you find the difference between the frequencies, you get a less bandwidth here. Okay. Here bandwidth what you get will be less than the bandwidth that you get in a higher frequency. So as you go up in the frequency in communicating with the other devices or the base station or whatever, you get more bandwidth. So you can communicate more. So it is very intuitively you can find out. See, suppose if it is kilohertz, that means you have only 1000 cycles per second, right? Whereas if it is 1 gigahertz, you have 10 power 9 cycles per second. So you have more frequencies more number of cycles within a given time. So you have more information that you can communicate if you have a higher frequency signal. So that's why narrow band means you have a limited bandwidth available for you to communicate. And if it is in the range of few kilohertz or few megahertz, defines whether how much of data you can send it in that particular time frame or in that particular bandwidth. Okay, so it is like a bit of the pipe, how much of water you can send it through the pipe. I hope this is clear. Now, before choosing any technology for IoT, we need to keep few things in mind. I said power consumed. Okay, how much of power will be consumed for this device to communicate with some base station? Because we are talking about only wireless. Please understand that mostly IoT has to have a wireless communication, because it is normally deployed and forgotten, or it's maintenance free, and we cannot connect a wire and then expect a battery, power supply connected to some wall socket kind of things we cannot expect, because the environment in which IoT devices are normally deployed are not very conducive for normal operation. So they need to be in a very harsh environment with limited power, with lots of noise around, and maybe closed indoor operation or outdoor operation. That means outdoor means there is a problem that it is exposed to heat and dust and rain or whatever. Whereas indoor has its own difficulties, because any wireless communication with a base station indoor will not be able to reach it because of the building and other things. In the industrial environment, because of noise introduced by the devices or the engines running, power being supplied to those engines, there are a lot of interference, RF interference, radio frequency interference will be there. So industrial things has its own limitation, and heat is a main issue where the operating temperature will be very high. Or in the harsh environment, it could be on a mountain over Himalayas where its temperature ranges are minus 50 degrees to maybe 100 plus degrees. So that is called industrial range. So we need to comprehend all these things before choosing a device, before choosing a technology, and we need to have all this in mind, that when we are designing something using IoT, these are the restrictions that we get while deciding some communication technology for IoT. Okay, now narrowband, I mentioned it. Now, as I mentioned, ease of deployment is very important. Okay. Now, let me tell you this particular communication, narrowband IoT, makes use of the licensed band. When I say licensed band, you must have seen these frequencies if you have heard of 2G and 3G later on. 2G operates under these frequencies. Okay. Second generation wireless, and another name for that is GSM. They operate in these frequencies. They are all fixed standard frequencies used by different countries. Japan, Europe, and India, US, they have different frequencies in which they operate. That's why the mobile that we get, you normally come across tri-band, whether does it suppose tri-band or, the mobile should have multiple band of frequencies. Why? Because when you buy a mobile, you don't know whether you will be likely to be only in India, or you are going to travel to Japan or Europe or US. Because different countries are using different frequencies, this device, even though it is maybe 2G stack will be running, 2G or 3G stack software may be running, but if the transmitter device in your mobile does not support these bands, tri-band, then even if you have all the software running, LTE or 3G is there, it will not be able to communicate if it is in a country where that frequency band what is used there is different and your mobile device does not support. So this multi-frequency support in mobile is important for this reason. Okay, where different countries have decided to use different frequencies, even though the technology 2G or 3G is same. When I say 2G or 3G, it means the kind of interaction, protocol, and handshake that happens between the mobile device as well as the infrastructure and at the background, whatever is happening. They are all fixed, they are standard. But the air interface, they say this is called the air interface, which could be of different frequencies. So that need not be same in all places. You keep it in mind. Now, this narrowband IoT makes use of existing wireless infrastructure that we have put for mobile devices, both GSM as well as LTE, which is similar or more towards 4G technology. Now, if you are having a 4G already, now our country has 4G already there, and LTE is also there deployed. Now, if you want to support narrowband IoT on LTE infrastructure, which is a mobile infrastructure, what we need is only a software upgrade on the mobile infrastructure to make it compatible to narrowband IoT. Now, let me tell you why is it different from normal voice calls that we make. See, LTE is some 4G technology which is already there with a lot of base stations. Assume that each of the base stations are uploaded with a new software, upgraded with new software, which supports narrowband IoT. That means the software stack running here is now capable of supporting narrowband IoT. Now you bring a device, IoT device, with the NB-IoT enabled. That means this can talk to the device, the network. Now, what you need on this end, you need a SIM card, as I mentioned, SIM M or E or machine dependent SIM card. It's not what we used in our mobiles. And we should have a number registered with the wireless provider. If it is a Airtel or a Jio, whatever network, you need to have a registered SIM of that particular service provider. Then what happens? Your device, IoT device, will be able to communicate. Now, the reason why we need a separate SIM, which is different from mobile SIM, what we normally use in our mobile equipment, is because our mobile SIMs or our communication requirements are for voice and, of course, data. You may access the data, email, all that. And then you also have a video calls. So your requirements on the mobiles are different. Your latency requirements are in terms of few hundred milliseconds. It's not very less than few 1 second or 2 seconds, but your data rate requirements are different. Download and uplink and downlink requirements are different, much more than what you need on IoT. And one more very important thing is our mobile devices are capable of radiating at a higher power rate. Okay, in terms of few watts, okay, or at least milliwatts of power it can transmit. So if you are having a device with a higher power rate, then the signal what it is transmitting is of good signal. The amplitude is very high. Then it can be operational in a harsh environment, and it can reach longer ranges. It can communicate with the base station which is at a longer distance, and more data can be sent. So normally what happens is, when you are in a harsh environment, when it is raining heavily or there is a lot of mobile devices in your area, then the bandwidth allotted to your devices will come down. See, the base station has a limited bandwidth. It cannot support everybody. Then if the signal strength is weak, it will sense that the mobile device is not able to send high energy signal, or if it is because of noise, there is a less amplitude is received by the base station, then it will bring down the amount of data that it can send it across. That's why dynamically the data rate of your link with the mobile station comes down based on the situation, based on the signal strength and the energy that you have on your battery, all those things. Now, what happens in the IoT device? It is always power constrained. So it will not be able to send it at a very high power rate. So the communication between an IoT device and the power station, base station, will be of low data rate. Data rate is low, okay? And then reliability of this connectivity is also low. So these devices know that I am connected to the base station, but there is no acknowledgement coming. Okay, it will not expect some acknowledgement from the other end that the data is received properly. So they manage different kinds of protocol. When they come to IoT, they transmit multiple times same data with different timestamps or same timestamp, so that one of the data packets are received on the other end. So there are some techniques used to cater for the low power that is available with IoT, and then it will not expect any acknowledgement from the other end, so that it doesn't have to keep their receiver on. so it doesn't have to consume power. It can go into sleep mode quite often. Whenever it wants, it will send it, and then it will wait for some specific time to receive it. Okay. So there are different changes done to the protocol, even though the infrastructure is same. That's why we need to have a different protocol defined as NB narrowband IoT. So if someone asks you, why do we need one more protocol if you are using the same LTE infrastructure, you can come up with all these answers to clarify that you understand what is happening. Okay. Now, one more thing, I will spend time later on. These devices, whatever we have, IoT devices, they are categorized as class A, B, and C. Okay. The IoT devices. I will talk about what is the differences between them and why do we need this kind of a classification from the device perspective, maybe in the later section soon. Okay, fine. I hope you understand. By now you might have read this also. So you can have 100K of devices per cell. That means per cell means you might be knowing it. Always the cell phone tower is divided into cells like this, hexagonal shape, so that it can fit into other cells, and each of them are handled by one base station. And suppose if it is all for Geo, okay, I am taking Geo, don't think that I am having somebody in Geo or Ambani is related to me. It's not the true, he doesn't know me, but because it is popular, I am bringing it up. So there are different base stations of the same service provider. Now, when they transmit, they are given already some bandwidth of frequency for them to operate. Government has given permission for Geo to operate on using these frequencies, suppose F1 to F2. In the same area, Airtel also will be installing their base stations and then operating in the overlapping area. So their range will be different from the Geo's thing. So Airtel will be using different frequency range within the same band. Okay, even though LTE or 3G, they follow some band. Within the band, multiple sub branches are there, and then they are allotted to different service providers. Now, even within that, suppose Airtel has one band, within that they will be using different frequencies, again a range of frequency or a particular frequencies for different cells. So suppose if they use FA, they use FB, they use FC, and then which is far off cell, they start using FA. That is called frequency reuse. The same Geo base stations, they start using different frequencies in different cells, expecting that the radiation from this guy does not overlap with the radiation from this guy. Okay, though they are from the same company, same service provider, they should not communicate. They should not interfere with each other, because if you are transmitting on the same frequency, you may start hearing somebody talking here, someone else will receive it. So that's why they space it out so that their frequency reuse is done such that this radiation will never overlap with this radiation. So they have to control the radiation power such that they are restricted within the cell. Okay, but they will not be so particular that this, don't expect that it's like a nation boundary that the RF signal will stop on this boundary and it will not go here. It will go further down, but it will be weaker when it enters the other cell, and your mobile which is there will be scanning all these frequencies and pick the frequency which is stronger enough so that it will always be connected to the nearest base station based on the signal it receives. So there is a lot of things going on in your mobile communication, but I will not go into details of everything. If you are from ECE background, you must be knowing all this, but CS guys may have something, some gaps may be there. That's why I'm filling it up now. Okay, now this enables IoT devices to send their data directly to cloud. Okay, what I mean by that, the devices are directly connected to the base station. There is no gateway coming in between. Now that puts a requirement on the device that it has to send sufficient power so that it can communicate with the baseband. So sorry, base station. That is the reason the power consumed by the devices which are using narrowband IoT is little more than other categories wherein they have a gateway. See, if suppose IoT device is there and then there is a gateway which is communicating with the base station, then the gateway may be connected to the power and it may have sufficient power to communicate with the base station, and it can consume more power. But IoT devices are always connected to the gateway, which are in a short ranges. So they can use less power to communicate with the gateway. It is also wireless. This is also wireless, but this is more power. Power is more, whereas power is less here. So if you have a gateway, you have an advantage that the devices has a longer lifetime, and they need to consume less power. Whereas if it is, in this case, narrowband, it is directly connecting to the network. So there is no gateway in between. So you have more power requirement here. But still, it says that 10 plus year, it can have a battery life, but it has to be tested. It has to be verified based on the usage. It may come down. Okay. And then it reduces complexity because there is no gateway business and it is directly talking. Complexity is reduced because these IoT devices are low power devices. Bandwidth is also low. They are given very less time to communicate. Okay. And data rate is also very less. And the sensor devices, this is acceptable because IoT sensor devices are tolerant to delays. Okay. Now, we are not expecting this kind of communication with the mobile devices, which we are using, but IoT devices are tolerant to delays. They are okay with low data rates because they are not human beings. So we can survive with feeding them little data or taking data in a very short spans. Few bytes only will be communicated and exchanged between the device and the base station. So another technology which is being used are FDD. FDD is a frequency division duplex. I will not go into this. It is a technology. It is a time division duplex, you might have heard, and frequency division duplex. It is for allowing multiple devices to connect to the base station. Okay, it's technology which that is. Let me give an example. Time division means what happens is, if suppose a device, multiple devices are there, and this is the time that which they have to communicate with the base station. Okay, now every mobile device are given one particular time slot so that they can multiplex their data. That means only during this time slot, one device is allowed to transmit. You cannot transmit whenever you want. So other time slots are given for other devices, so that it's like a technique used for multiplexing different devices to use the same frequency over time. Okay, because of giving some specific time for communication, we are multiplexing different devices and we allow them to communicate with the base station. That is called time division duplex. Same thing you can do for frequency division, wherein you say that this frequency, a particular frequency F1 is given for one device, F2 is given for other device, so they can only communicate using that frequency. So that because you are having a bandwidth, multiple frequencies are there, each device uses different frequencies for communicating. So that's what is called frequency division multiplex. So this device uses FDD, okay, because time division needs lots of hardware built into the chip or IoT device to measure the time and then communicate during the time. So it consumes more power and it improves, increases the complexity of the device. Whereas I mentioned that this is a less complex. That's why FDD is used, wherein choice of frequency is easier, whereas the choice of time is very critical and very accurate. It has to be. So frequencies also has to be accurate, but implementing them in the hardware is easier. And single antenna, I will not go into the MIMO now because I am already explaining a lot of things which you may not be interested. I'm not sure. MIMO is, in simple term, multiple antennas will be there on the device side as well as on the base station side, and they communicate using all the antennas, so that even if one of them is not connecting well because of some shadow or whatever, other antennas can communicate successfully. So MIMO is pronounced as MIMO. It is highly reliable circuitry, okay, because multiple antennas are used to communicate, and reliability is good, and signal strength is overlapped between different communication coming from different antennas. So you have a better signal strength on the receiving side. Okay, that's all. I am not going to go into the detail. These are the different applications which are using this NB-IoT. You can see that all of them use many devices because this is meant for 100K or 50,000 devices or so. So it is meant for applications wherein more devices are there in a given area. Okay, and it's a wide range. It has got 10-kilometer range, but don't think that it is wide. Compared to all the technology that I am going to explain, this is the lowest among all. Okay, so it is good in terms of density of devices. 50,000 devices per cell is really huge. In our mobile case, it will not be this many. Number of users in a cell could be few thousands. It won't be 10, 50,000 or so in a normal voice call. Okay, whereas because IoT devices are low power and data rates are low, we can put more devices and same base station can communicate with all the devices. That's the basic understanding you should have. Peak data rate of dates are very few kilobytes. It's not in megabits per second. It's kilobits per second. Remember, it's not byte, it's bit. And latency is less than 10 seconds. Okay, and then they can occasionally send data and receive data. Okay, and communication between uplink and downlink. It is which are the vendors using it? Chips. They provide, ARM processor or this is called PHY device, physical interface device for NB-IoT. Okay, we need a hardware chip. These are the companies which are supplying that. Okay, and it provides good QoS, quality of service, and it uses licensed LTE spectrum. So it has got more cost involved. Implementing them, additional cost is involved because you need to have the licensed spectrum you have to buy. So it is expensive. Okay, I hope you have a good idea of what is NB-IoT, what are the different pluses and minuses of this. I'm sure you will be able to write a story, or if someone asks you, you should be able to give a beautiful, convincing story about what it is. Okay. Now, let me take a break to know the time as well as for any questions around. Okay. How large is cell for mobile phones? Okay. Let me tell you what happens in the mobile phone. It depends on two factors. Okay. Device density. Okay. Number of users in a given area. Density. Okay. And number of, device density. And then the distance between the base station. Okay. Distance. Now, these two are indirectly proportional. 1 by this. What is this called? This is distance. So when you have more devices, okay, in an auditorium or you are watching an IPL cricket match, there are very huge number of lakhs of people are there in a constrained area. Now, suppose if I have a base station here, okay, naturally we need to keep it very close to this stadium, because you cannot have a distance which is more and then expect it to support multiple users. The reason is, when you have a strong signal, the mobile things can communicate. There won't be any retelecast of something, or retransmission of some data. Is a reliable communication happening, and more devices can be handled. That's why in urban area, you see that the range is in terms of some kilometers. Okay. Whereas in rural areas, the distance could be little more. It can be 10 kilometers or 20 kilometers. And even the signal strength is weak, because you are sending the data, number of users are less, you can still have a connectivity. So we cannot exactly decide how much it is. It could be in the range of few kilometers, 2 to 3 kilometers to even 10 kilometers or something. But 10 kilometers is a little longer shot. Okay. The base station should have the support of sending the signal up to that point. Okay. They actually do different transmission wattages, kilowatts, power. How much they transmit depends on where they install the base station. Okay. If they are installing it on a dense area in a city, they will be transmitting at a low power, maybe few kilowatts or maybe less than kilowatt, but maybe tens of hundreds of kilowatt, maybe when they are installing it on a rural area, because they transmit more power so that they get more range, and because the density is less, they can afford to do one particular base station and they can send it. But it's in the city, if they transmit, one more problem I'll tell you. As I told you, the cells are limited in shape. Okay, distance is limited. So in a city, you need a one base station for crowded people here. Okay, if suppose this is a densely populated like Mount Road or whatever, no, center city, center part of the city, then more number of people are there. So you expect more users to be there. So same base station cannot support more number of people. So you need to install one more base station in the nearby place itself. That means what they transmit will be of low power compared to what they do in a long range cases. So this is very dynamic. I can't give you one single number, but that is what is the situation. Now, to avoid frequency overlap, they may leave some gap between two frequencies. This lead to waste of frequencies. Then how this affect the cost of building the spectrum? Okay. See, that's why they use different technologies. Okay. It's not that they waste some frequencies in between, because we have OFDM and spread spectrum. Okay. If you have heard of spread spectrum, what happens when spread spectrum is spread. Okay. If they are spreading the frequency over the whole range. Okay. But for every user, they use a particular code. Okay. It is called cipher. Okay. Cipher. So they modulate it using the cipher, which is some long 128-bit or some unique bit pattern for every user. So they modulate it using that, so that when they receive it, they match it with the modulated cipher, and then they extract this signal transmitted by a particular user. So in that case, they don't waste any frequencies. They use the complete spectrum, and the data of a particular user is spread over the whole range. Okay. That is called spread spectrum technology. Other technologies are what I explained as FDD and TDD, all those things. There, they may have different frequencies, but what they do is they allot in such a way that they use a different time frame, that the overlap is less, and the frequency transmission is also not for the entire duration. They do a short pulse, short communication they do, so it will be immune to noise. And they also take care of different other modulation technique. That's why modulation comes. They don't send it like normal frequency. They modulate it using some quadrature phase shift keying. They phase shift the key, the sine wave, they phase shift it so that they can communicate different things. Okay. So I will not go much detail, but I think this is enough for right now. Okay. Some more questions are coming. Okay, good. So let us see now long range. Okay, this is another technology which I am going to spend less time. The name mentions that it is for long range. So 20 kilometers or something is the range. And then it's a full duplex. Okay, full duplex means at the same time, both transmitter and receiver can send the communication. Okay, at the same time, both can be sending data. That is full duplex. Half duplex means this is full duplex. Half duplex means at a given time, either one of them can send or one of them can receive. That is called half duplex. So at the same time, both will not be able to do. But at particular time, one fellow sends, and then at different time, the other guy sends it. So the direction of transmission is not overlapped in time. In full duplex, it is overlapped in time. Whereas another one is a duplex device, not even half-plex thing. In that case, only one kind of communication is possible, only one direction. Okay. Normally, this is of useless because you need to communicate back also. So either you will have a half duplex or full duplex systems. In this case, it is a full duplex. Okay. Now, this is not using the existing wireless infrastructure. Okay. It doesn't use any existing wireless infrastructure. It uses ISM band, which I said industry, scientific, and medical, which is a free unlicensed band, free band. Okay. It is available for everyone. Our microwave oven, our cordless phone at home, and our Bluetooth, okay, they all use the ISM band. And even Wi-Fi, they use. That's why we are able to keep our Wi-Fi router and we can transmit in our area, because it belongs to the ISM band. You don't need to pay for using your Wi-Fi, except for the service provider. You don't have to pay government thing. So this is also using such a band. Now, another thing is they are installing multiple base stations. They are all base stations, okay, and gateway, or you can call it as a gateway, which connects to the backhaul. Backhaul means which is aggregating different base stations and then sending it over their own network, and then they may use internet or phone network or whatever to communicate with the whole world. Okay, now they devices which are there, they communicate at the same time with multiple base stations. Okay, normally what happens in our mobile technology is we normally are connected to, suppose if you are having a mobile, you have a base station, you may have an overlap of base station of both. Okay, this is a base station 1, this base station 2, your mobile is here, you are in an overlap, and you will communicate with the base station which is very near to you compared to the other one. Suppose if you are moving, then what happens is this base station knows that there is another base station which is nearby, and they communicate with each other saying that, hey, I am handling the connection with this guy now. He is going in a car, now he is getting into your area. So I am doing a handoff. That's called handoff happens. So this base station hands off the connection to this base station. Once you come closer to this fellow, this guy takes care of you and this guy drops you. So that's why when you are on a highway and you are a mobile phone, sometimes you lose connection completely, you lost connectivity. That is because the handoff is not happening properly. Okay, either because of signal strength problem or the person who has written the software for the handoff has not done a good job. They has not learned the computer science properly or ECE properly. Okay, so fine. Now multiple receptions. This now on more advantages when you have devices which are communicating with multiple base station. These base stations know where they are in the GPS coordinate. Okay, they know where they are. Suppose these base stations are in these locations. Okay, now when you have an IoT device communicating with multiple base station, the advantage is they can do a localization. Localization is a very important technique in IoT. Okay, that means you should know where exactly your IoT device is with respect to the some coordinate. Okay, it could be GPS, longitude, latitude, or whatever may be. Okay, you should be able to map it to the particular Google map or whatever. That's why when you are having in a car, you can see that you are moving in a road because localization is done. Where you are exactly your car is done using the mobile tower you are connected to, and they do a triangulation. This is called triangularization, using the triangular coordinate, and they can measure the distance based on the strength they are receiving from you. The base station can they can guess your estimate your position, and they give you the coordinate position. Okay, this is what is happening when you are moving in a car also. So this is the called localization. Maybe if I have time, I'll talk about it later. So long range, this is following the IEEE standard, uses ISM band, and different frequencies are used on different regions. This is, I think, US, Europe, and Asia. Okay. Ranges are 5 to 15 kilometers. As I told you, this is little more than what you saw in the NB-IoT. Okay. So that's 10 kilometers is the lowest range. This guy is little more than that, 15 kilometers or 20 kilometers, less than 20 kilometers. Battery life is also more than NB, because you can guess now, because it is having a gateway in between. So they don't need to transmit high power. So you can see that it actually reflects in the battery life. That is less than 10 years. This is more than 10 years. And the range is more, urban range and rural range are different. As I mentioned, it's the same reason I gave you for mobile. That is also true for IoT also. And it uses security, CRC encoding, so that even if there are errors in the data or any intrusion is there in between, then you can catch it. Very high immunity towards interference. Interference is more, immunity towards interference is better. Okay, I don't know why it became yellow. Let me wait. Okay, so interference is very high because multiple devices are receiving it. So if this signal is weak, this guy will receive it and then send it. Okay, they are getting the same data, but one of them will use this to send it to the backend. Okay, so that is how it is advantageous to connect to multiple base stations. Okay, so I hope you understand overall picture of what it is. I am going to share some material also with you, which is a nice comparison of these technologies. I wanted to go through it as a homework. I will call it as an assignment or something. We'll see. We have to give some assignment. I will maybe think about it tomorrow. I will give you. Okay. Now, where all it is deployed, I will not go into the detail. LTM is there. Yellow is there, and in Europe, some part of Europe. Okay, France, Germany, and Canada, and you have LTEM, which is in US and in Australia, and blue is also there. NB-IoT is here. Okay, Europe, China, Russia, and then Mongolia, all these areas, and even in the Middle East and some part of South Africa. So these are all the areas, and even South America. Okay, so this is the by 2019 it was. Now it should have been better off. Okay. Now, this is the most important technology which I want to spend at least 10 minutes or 15 minutes before I see some questions. No questions, so good time to go. 5G is the latest technology which is on the installation stage now. Okay, in India, latest article I read, maybe I will share it with you in Times of India. Airtel actually has overtaken Jio in terms of coming up with the 5G infrastructure in Hyderabad, I think. Yeah, Hyderabad, they have already proven that 5G will run. Only thing is they are waiting for the government approval and no auction. I mentioned it to you. So they are planning to do it in March 2021. I think still auction is not done, and a very expensive affair. The auction is very expensive in terms of crores of rupees, and you know that 2G scam, you know. I hope there is no 5G scam now. In the preparation now, but it will happen by mid of 2021, and actual 5G rollout will happen maybe by end of this year. Okay, that's what is expected to happen. Now, what is 5G? 5G is, see, once the 2G, 3G, 4G, 5G, one important thing changes is the frequency of operation. Okay. They give different frequencies for different technologies or generations. So one good thing about 5G is they have frequencies under different frequencies, ranges. Okay, low band as well as high band. This is the highest band that is given now, right now. Okay, satellite communication was using, but now for a ground communication, they have given this highest band. Now, once the frequencies, as I mentioned, frequency is more, you can send more data, right? If frequency is more, data can be more. So you get a higher data rate. That's why this circle is bigger in shape. Okay. As you go up, the shape of the circle goes up because it can handle a lot of data rate. Okay, you can even download an HD film movie in a few seconds. So 5G represents some new challenges. What are the challenges? They are intended to support faster mobile band speeds. Okay, the speed they need to support is much more. Okay, speed is the tense. A faster mobile band means broadband is data communication, not a voice data. It's a file transfer or a YouTube or video. Okay, so they need to support higher data rate at the lower latency. The latency is in terms of 1 millisecond. Okay, less than 1 millisecond. Remember this number. All other technologies are much more than what you get in 5G. That means you can get instant response to what you do. Gaming, especially video gaming, multiplayer gaming, you need to buy a laptop on mobile connection with a 5G. I hope you are not planning to become a full-time gamer, but if you want to do, you need to understand technology also, so that you make a proper choice of which NVIDIA graphics is working, which laptop is coming, and what mobile connection you need to have. All that you need to have technology knowledge to have to become a good player gamer also. So this will require wireless operators to have access to large amount of spectrum. So that's why they need a wider spectrum, because they need to support wider data rate. So in low band, in low frequencies, you can achieve higher range. Okay, you can achieve higher range in low band. Here you can achieve higher range because the atmosphere does not absorb these frequencies whereas these frequencies, they get absorbed in the atmosphere. Okay, even they are not, they cannot enter into the building, or those kind of restrictions are there in high band. So that's why in high band you get less range, more data rate, whereas in low band you get more range, because low band frequencies can go longer distances, but they cannot support you higher data rate because they have very few kilohertz of bandwidth to communicate. Okay, so exactly different. Service providers are T-Mobile, AT&T. I mentioned US, but in India it will be Airtel and Jio and Vodafone. I'm sure. What else? Who else is there? I forget. Devices are Intel, Qualcomm. They 5G chipset they give on the device side as well as on the infrastructure side. Okay, yeah, I put it here. And by mid 2021. And overview. Okay, don't get perturbed too much. I will explain you. These are all, see, what 5G, what happens is they make smaller cells, okay, and then they also have a longer cell, okay. So they are mix of both. That's the advantage. So you are already always connected, but if you want a higher data rate, you have to use the smaller cell. But if you are in this region, maybe you can live with the larger cell, which is supported by LTE. Okay, LTE and 5G, they work hand in hand. Okay, even 2G, 3G, wireless, Wi-Fi, they also work with Wi-Fi. So the advantage is they mix different wireless technologies to achieve the data rate and latency requirement that this 5G promises to deliver. Please remember, 5G promises to deliver that service requirement. We have to wait and watch when it really gets rolled out, how much of latency it gives, how much of data rate it gives. Okay, they promise you something, but what we get will be certainly always less than what they promise because of different technology limitations and the problems that they have not even encountered. So don't worry, these are all the individual base stations. They have a smaller cell and they connect to the different backend side, and then it's called a front haul and back haul. And one good thing you remember that 5G operates on IP network. Mostly the backend is IP network, and they use Wi-Fi, LTE also along with their own 5G technology. They use femto cell, okay, micro cell, nano cell. You might have heard of. This is femto, very small cells they use, so that they can, the range is very small, but the data rate is very high. Okay, that is what, if the cell size is reducing, you can imagine that the data rate is more. If cell is very large, the data rate is low, range is high. Okay, I have a logical understanding of them. Round trip delay is 1 millisecond, very, very less. And they use various IP devices they can connect it to. And it's called tactile internet. That means they have low latency, but high availability and reliability. Okay, this is a bad combination, a very difficult combination. I am not saying bad combination. Ultra low latency along with availability and reliability and security is a very, very tough combination. And that's why it's called tactile internet. 5G supports that. Okay, fine. Now I'm going to give you a very high-level overview of that. You will have a better idea. The backhaul connects the fixed cellular infrastructure. Okay, that means the base station and then BTS, BSS, all that stuff, to the core telephone network. Currently also majority of internet communication is happening over the existing telephone network also. Under the sea cable, either fiber optics, now they are laid it under sea cable. Otherwise, even the telephone cables are used for communicating internet connectivity over the telephone network. Okay, so they use whatever connectivity is there, they will use it. Backhaul carries traffic between local subnetwork and the core network. Always the network is front end, front haul or whatever, the last mile, I said, last mile. Then you say you have a local subnetwork, it is all subnetwork, okay? And then core network. Core network is connecting multiple subnetwork, okay? So that anything coming here can go to any other network. That is what is the core network. Core network is a backbone. We call it as a backbone in internet terms. Backbone is something like our backbone, connects with anything. So any traffic, if it has to reach something else, it has to go to the backbone and then get routed here. Okay, that's how even internet traffic flows. So you should know these names so that you have a better idea when you see some pictures giving this connectivity. So remote radio heads are called base stations in the 5G world, and then baseband unit is which is little bit connecting multiple RRH. They use multi-tier architecture. That means they use 4G cells for long range. They use even Wi-Fi and multiple 5G. They use, okay, I mentioned it, Wi-Fi, LTE, millimetry wave. Millimetry wave is the high band wave, okay? What I mentioned, 28 gigahertz to some 54 gigahertz or something. Okay, this is called millimetry wave. Millimeter wave is because the frequencies of these high waves are in terms of millimeters, okay? You know that CF, okay? See the relationship between F and T and C, okay? Fine. The speed of light and then frequency of signal. Okay, so 5G uses software-defined radio networking. That means the whole network is software controlled, okay? 4G and the other 3GS are not, they are also running software stack, but 5G is software network means you can actually selectively give the traffic different treatment, delay, latencies, and the data rate you can define based on the service. Suppose one customer U1, user U1, user U2, they have registered for different services. You can cater for those services, selectively. Okay, that is called software controlled networking, and network virtualization is giving a different feel of the network to different users. Okay, they will not see the same kind of a network because a person who is paying less, they will get a less service from the network. Okay, it is called quality of experience. Okay, now what is 5G for IoT? It becomes 5G will be used as a protocol. When you guys get into industry, you are likely to be using 5G in your IoT network for sure. So it will be further enhanced. LTE capabilities will be with longer range and facilitating low power consumption. So IoT will be using both LTE and it will be improved to 5G, wherein you have more high data rate, okay, lower latency requirements are there. You can go for 5G, okay, if your devices and applications need that kind of a connectivity. Please remember, you should go for 5G when you are very particular about low latency, 1 millisecond or less. But you should also remember that it is a licensed spectrum, so cost is more and technology is latest, so there will be availability will be less, but reliability will be high. Okay, so all these things you should remember when you are choosing something. And it's going into initial trial now. Soon it will be used. This is extended reality, like a virtual reality. You have this kind of applications where you need a gaming and instant, even medical, where you want to do a surgery over remotely, then 5G has to be used, where reliability is important and data rate is important. So the peak data rate is in terms of gigabits per second, not kilobits per second like what you saw in the previous technologies. And peak data rate is much more than the average data rate. Okay, they are different. Lot of differences there between this is Mbps, this is Gbps. And future network capable of next generation 5G, they will be useful for different applications based on the requirement. So the physical 5G network is sliced, okay, into multiple virtual logical networks because it supports that virtual logical definition. So 5G can be used for different services. So I think this much of introduction is more than enough for you guys. And if you want to know, you can always read up more. Okay, I think I have exactly come into the timeline. Okay, a lot of questions there. Let me go one by one quickly. So 5G can only operate over a small area. No, 5G, I use LTE also. So I think these questions came up before. So if you are having overlap of LTE, you can have a long range, but the data rate, what you support in the long range scenario will be less, but you will not lose the connectivity. More base stations, yes, 5G needs more base stations and they have to provide MIMO technology. Okay, they will provide MIMO technology and they will also use Wi-Fi to their advantage. So they can manage, balance out the number of base stations that are needed, and there must be limit up to which one can buy spectrum during the auction. Yes, of course. I don't know. I have to ask Ambani only. But they have to be fair to all the service providers, and based on the money involved. See, this is all auction. Auction, there is a money involved. If Ambani has a lot of cash in his packet, he can overthrow anybody and get more. Okay. People say that there is because of the political clout it is being done, but he also has a lot of money because of his business acumen and his talent in spreading whatever field he gets into. He becomes successful and he spreads all over the thing, and the service provider is also good. So because of that, he has more money in his kettle, so he can buy more spectrum because it's auction. So as and when more people come up and pay more, they will get. So I cannot answer anything. Let us wait for the auction to happen and see. Latency is due to processing in the devices. How does this differ from 3G to 4G? Okay, latency is not due to processing of devices. Okay, it's not because the devices are not capable of processing. The latency is due to the technology what is used, the connectivity you use. Okay, if it is 3G technology, even if you use Core i7 processor or some high-end chip here, you run it on gigahertz, does not matter because the pipe that you have is limited. Remember that devices are finally connected to the mobile station through this pipe. If the pipe is narrow, whatever high-end device you have, is of no use. It is similar to running Windows 10 on a 10 years old laptop. If you use Windows 10, that doesn't mean that you can run faster. Or if you use the latest iCore 7, but you use now Windows 95, then also is a problem because processor may be powerful, but the OS what is there will not be able to use the multiple processes effectively. So it is a mix of both. Okay. So latency is due to the technology limitation, not because of the device limitation. Okay, very good question. And I can remove all the doubts that you have. I'm happy that you guys are very interactive. Changes in the baseband, so backend and base stations. Okay. Yeah, you are right. Not only the backend and base station. Yes, base station is the frequency what is being used and the technology what is being used